So my topic is what factor decide the posterior slope angle of the tibial articular surface. And what we found that the posterior slope of the tibial articular surface is created by the posterior rotation of the tibial condyles. So in 2012, Dr. Bellman established the concept of the constitutional varus. So in the coronal plane, in knees with medial OA, we know the tibia has proximal tibia vara with the medial shift of the tibial articular surface, like that. So how about the sagittal planes? One case have a minimum posterior slope, and the another one, the maximum posterior slope. So do you know what is the difference? So on the proximal tibia, on the lateral view of the X-rays, we drew 6 lines, and the 4 angle parameters, and the 3 distance parameters were measured. And we evaluated 100 cases, and the flexion angle between the anterior cortex of the femur and the tibia, the average is 55.2 degrees. So in the medial tibial articular surface, there are 3 posterior slopes, M1, M2, and M3. So in this study, M2 was evaluated. So okay, please check each by each. Step 1, we draw the line and along the anterior wall of the tibial shaft. And then we draw the line 2. Line 2 is the medial articular surface. And you can now measure the angle, medial posterior tibial slope. The average is 9.2 degrees. Okay, the another one, the line 3 is very important. Line 3 is the line along the anterior wall of the tibial condyles. So I repeat, the line 3 is the anterior wall of the tibial condyles. And you can see we measure the CAWA. This is the angle between the line 1 and the line 3. You can see the CAWA have the correlation with MPTS. So you can see the correlation between the CAWA and MPTS. Also, I measured the number 3 angles. This angle is the CAAS. This angle is between the line 2 and line 3. You can see the CAAS do not have correlation with the MPTS. So this result shows that the posterior tibial slope is mainly created by the posterior rotation of the condyle. And then we measure the distance of the tibial condyles. And the length of the tibial condyle does not have correlation with the MPTS. And then we also measure the distance from line 1 to the midpoint of the tibial condyles. This distance also had a correlation with the MPTS, which means that the articular surface shifts posteriorly according to the posterior rotations. We also have measure the posterior condyle offset ratios. You can see the ratio as the lower correlation with MPTS. So the posterior offset may be larger according to the posterior rotations. So if you draw the contour of the one case with the minimum posterior rotation, the another one with larger posterior rotations, and the superimposed, you can see the difference. The anatomic axis is the same, and you can see the difference of the position of the mechanical axis like that. Okay? So when you think about the tibial component alignment in the sagittal plane, it needs with a larger posterior rotation of the condyles. You can see the posterior slope angle and the location of the tibial components is different according to the landmarks. So in this with the medial OA, posterior slope of the tibial articular surface may have a correlation with the posterior rotation of the tibial condyle, the posterior shift of the tibial articular surface, and the larger posterior offset of the tibial condyles. So when you think about just for the tibial condyles, you can see this is the line on the anterior wall of the tibial condyles, and this is the line of the medial articular surface. So the average, the angle of this one is 96.4 degrees, which means the tibial condyle itself does not have a posterior slope. And you can see the another line was drawn along the anterior wall of the shaft. And then we measure the posterior tibial slope. The angle is 9.2 degrees. So the tibial condyle posterior rotation creates the posterior slope of the articular surface relative to the tibial shaft. So in the coronal plane, constitutional valves are established by measurements, and we are now proposing in the sagittal plane for the concept of the constitutional posterior rotations, which means the tibial condyle posterior rotation and the posterior shift of the tibial articular surface. So why does it happen? So hypothesis for the formation of the posterior tibial slope by the constitutional posterior rotations. So our theory was that the frequent weight loading to the posterior part of the tibial condyle may induce posterior rotation of the tibial condyle and make a posterior tibial slope relative to the tibial shaft. So when you think about the full extension of the knees, you can see this is the knee without posterior slope. Okay, so this is the slope with the larger posterior slope. Okay, this is the femur and the tibial condyles, and with the larger posterior slope, like that. The tibia, as I told, the tibia has the larger posterior slope, which means that from the point of the tibial condyle, the tibial shaft tilt posteriorly. It's not the full extensions. So if you set the femur and the tibia in full extensions, you can see the tibial condyle and the tibial articular surface and the crucis ligaments are hyperextended. The same thing at the 90 degrees flexions. You can see the 90 degrees between the tibial condyle and the femur is not the same with the 90 degrees with the tibial shaft and the femoral shaft. So when you measured gap balancings at 90 degrees, the flexion at 90 degrees between the femoral shaft and the tibial shaft is not 90 degrees for the tibial articular surface and PCL. And I think the posterior rotation angle of the tibial condyle influences the mechanics of the implant knee and the clinical result. And if you use a CRTK, you must be very careful to evaluate the gap balance at 90 degrees. Actually, I do not recommend the CRTK with larger posterior slope. Because if you evaluate the flexion gap like that and expand the knee joint, you can see the PCL is standing up and the femoral condyles moving superiorly and posteriorly. It's not accurate. So in this, with the medial OA, with the posterior rotation of tibial condyles, our questions are, what is the normal posterior slope angle? Where is the center of the tibial articular surface? And how to set the posterior slope angle in the CRTKA? And the full extension may be hyperextension for the cruciate ligament. And how to correct the posterior rotation and slope. So our suggestions, currently our suggestions are PSTK is more reliable for the knees with larger posterior slope, and the no posterior slope, and the medial gap control technique is more reliable, and the RM technique for rotational alignment, the tibial component, and the reduction osteotomy, I think is recommended in the medial and the posterior edge. So the concept of the constitutional posterior rotation of the tibial condyle will open the new method to decide the tibial component alignment in the sagittal plane. And thank you for your attention.